try another example now. This time I'm going to give you the zeros. So again, I want you to find the polynomial function for the zeros 1, 2, and 5i. Now, I know it looks like you only have a, focus that, sorry. It looks like there's only 3 zeros. So you might think that it's a degree of 3. But remember what I said, if there's an imaginary or a complex or an irrational zero, so this has a pair. The only way you ever would have gotten 5i is if you also have negative 5i. So x is equal to positive and negative 5i, because the only way you'd ever get an imaginary number is to take the square root of a negative. So my zeros are actually x equals 1, x equals 2, x equals positive 5i, and x equals negative 5i. So now you see you have 4 zeros, so my degree when I'm done should be 4, because it's the least degree polynomial. So here's my 4 zeros. I want to convert those into factors. So the first one is x minus 1. Remember, because we're taking the factor citing equal to 0 to get the opposite answer here. X minus 2, so if I set that equal to 0, I'd get x equals 2. I have an x minus 5i and x plus 5i. So I know that those look a little bit scary, but they're really not that bad to work with. When you start foiling, what you're going to really want to do is kind of clump together your real answers and then your complex answers. So I'm going to foil the real ones and I'm going to foil the imaginary ones. So I know that looks pretty scary. Let's go ahead and get that out of the way. So when I foil this, you get x times x is x squared. You do the outsides, you get plus 5ix. Insides, you get minus 5ix. I know that looks pretty ugly, but notice that it does cancel out. So those will cancel out right away. Negative 5 times positive 5 is negative 25. I times I is I squared. So remember, I squared is really just negative 1, so that's really negative 25 times negative 1. So this factor is x squared plus 25. Which, think about that. Out to the side, if you were going to do x squared plus 25 equals 0, and if you subtract 25 from both sides and you square root, you get x equals plus or minus 5i. So you kind of see where that came from. All right, now let's go ahead and FOIL our real zeros here. So I've got x squared minus 2x minus 1x plus 2. So when I put that together, I get x squared minus 3x plus 2. Now I need to FOIL these together so that I can get my 4th degree polynomial. So again, I'm going to take everything in the first trinomial, multiplied by both of these. So if you want to show what you're doing, you got your x squared multiplied by x squared plus 25. And then I'm going to take my negative 3x and multiply it by x squared plus 25. And then take my plus 2 and multiply it by, ew, that's ugly, x squared plus 25. So now I just need to multiply and simplify this out. So x squared times x squared is x to the 4th plus 25x squared minus 3x cubed minus 75x. Distribute this, plus 2x squared plus 50. And obviously that is not in the right order, so I'm going to put my x to the 4th first. And then I've got a minus 3x cubed, so I took care of that. I've got a 25 and a 2x squared to give me 27x squared, a minus 75x, and finally plus 50. Phew. And again, finish it off. Don't forget, this is an equation, so I want to set it equal to y or to f of x. And we're done. All right, let's try another one. Let's let's look at one that only has 2 zeros. Here, there it is, 3. So I'm going to tell you this time that one of my zeros is a fraction and radical 5. So think about that. If you ever have an imaginary or a radical, it has to come in pairs. So we must also have negative radical 5. So I actually have 3 zeros here. So this is going to have a degree of 3. All right. So let's start with the fraction. We've got x is equal to 3 halves. Let me just write these all out. X is equal to radical 5. X is equal to negative radical 5. On this fraction, if I multiply both sides by 2, and again, some of you guys are going to figure out what this is really quick, but multiply both sides by 2, so I have 2x is equal to 3, and then remember I'm trying to set this equal to 0, so I'm going to subtract the 3 from both sides, so there's my factor, 2x minus 3. Now this factor right here is x minus radical 5, and this factor here is x plus radical 5. So again, I'm going to FOIL those first because they're conjugates. Remember, that's a conjugate pair, and then the ugly stuff should cancel out. So I'm just going to write this on there. Conjugate pairs, when you multiply them, come out looking pretty nice. So x times x is x squared plus radical 5x minus radical 5x. Those will cancel out right away. And then negative radical 5 times positive radical 5 is negative radical 25, which is really just x squared minus 5. Again, think about that out to the side. If you had x squared minus 5 equals 0, you would add 5 to both sides, and you would get your plus or minus radical 5. So at least you can kind of see where that's coming from. You don't have to do that work, I was just showing you. Drop this other one down, so I have 2x minus 3, and you just need to FOIL. This one's actually not too bad here. So I've got 2x times x squared is 2x cubed. I've got negative 3 times x squared is minus 3x squared. I've got 2x times negative 5 is negative 10x. And finally, positive 15. I have them in order. Make sure that your degrees are in descending order. Set it equal to f of x. And you are done. All right, one more example. I'll make a new video for that one, but make sure you guys watch this one because this one is, I'll just keep going on here. Never mind. All right, last one we're doing. All right, so I'm going to say that I've got 2i, and negative radical 6. So it looks like I just gave you 3 examples. But anytime you have an imaginary or a radical, it comes with a pair. So just because I've got 2i, that means I've also got negative 2i. There's the pair. Since I've got a negative radical 6, I also have a positive radical 6. We always get pairs. Don't forget about those. If you do forget about them, you're going to have a very, very ugly looking polynomial because you'll have radicals and i's in it. Okay, so let me write these all out. I've got x equals 2, x equals 2i, x equals negative 2i, x equals negative radical 6, x equals positive radical 6. So 1, 2, 3, 4, 5. My degree on this one is 5. Remember, that's called a quintic. All right, let's change these to factors. X minus 2, x minus 2i, x plus 2i, x plus radical 6, x minus radical 6. And maybe think about what I'm going to try to FOIL first, because I want to get rid of any imaginary radicals that I can. So I'm going to leave the x minus 2 alone. I'm going to go ahead and I'm going to put my imaginaries, or FOIL my imaginaries first. And then I will go ahead and FOIL my radicals. So again, some of you are going to start skipping steps, and that's fine, but I'm going to show all the steps. So x times x is x squared. I've got plus 2ix. I don't know, I guess you could put 2xi. You're going to cancel them out anyway, but it doesn't matter. Minus 2ix. Those are gone. Negative 2 times positive 2 is negative 4i squared. So what that really says is x squared minus 4. I squared is negative 1. So it's really x squared plus 4. Let's do that same thing with the radicals. So x times x is x squared plus radical 6x minus radical 6x. Those cancel out. Positive radical 6 times negative radical 6 is negative radical 36, which is really just the same as 6. So there's my second factor. Nice looking factor anyway. Finally, drop down that first one. If I forget about that, then I'm not going to have an x to the 5th, and I won't have my degree 5 with my 5 original zeros. Now it's just a matter of FOILing this all out. So I've got, let's see, x squared. I'm going to go ahead and do these two first. So I have x to the 4th minus 6x squared plus 4x squared minus 24. If I'm going too fast with the FOILing, pause it. So I just FOILed my purple and my green set of parentheses. I'm going to drop down my x minus 2, and I'm going to multiply all of these together. So I've got my x times this trinomial, and then I've got my minus 2 times the whole trinomial. So I just need to distribute this and combine like terms. So x times x to the 4th is x to the 5th minus 2x cubed. I'm just distributing here. Minus 24x minus 2x to the 4th. Negative times negative is positive 4x squared plus 48. Check to see if it's in order. I've got my x to the 5th first, but then I need my x to the 4th next. So I've got x to the 5th, and then I've got my minus 2x to the 4th, then I've got to do minus 2x cubed plus 4x squared minus 24x, and finally plus 48. Phew, that was fun. Make sure you set it equal to f of x, and you survived. Go ahead and try the some of the buzz assignments with this, where you have to actually go through and FOIL yourself. And I'll see you guys in class.